Hey everybody, this is Chris McClure. We're going to now take a look at polynomials, a quick review of what they are and what we can do with them. Alright, so here we go. Get everything set up here. Alright, dark blue ink pen. Alright, so we are going to first recognize what a monomial is, and it shouldn't be a surprise. This is a polynomial that has just one term, hence the monomial. The meal refers to a term or a sign, so monomial as in one term. So a monomial is a single term polynomial that is basically the product of a number times a variable raised to a power. Now, just a word about notation is that the A here refers to some constant, as in like a real number. And then the X letter of the alphabet refers to some variable. We oftentimes in algebra will use the early letters of the alphabet, A, B, C, and so forth, to refer to constants, to represent constants. And X, Y, Z, the later letters of the alphabet, to represent variables. And then the K is going to be, as in this K right here, this exponent, will just be some number, as in an integer. Okay. So we have a monomial, which is basically a constant times some power of a variable. We refer to A, this constant multiplier, as the coefficient of the monomial. The K, which is the power of X, is called the degree of the monomial. The degree of the monomial. So, for example, we have 6x squared monomial that has a coefficient of 6, a degree of 2. You might have the monomial with negative square root of 2 times x cubed. Well, the negative square root of 2 is the coefficient. And because of the exponent of 3, this has a degree of 3. Now, a number by itself could be thought of as a monomial with a coefficient of 3 and a degree of 0, because of the fact that we can think about 3 as 3 times 1, but the 1 can be thought of as x raised to the 0 power. So that would be a 0 degree monomial. We have negative 5 times x, where negative 5 is the coefficient, and you have a power of 1 on the x, so this would be a 1 degree or first degree monomial. We have x to the 4th power. Well, that's a monomial with a coefficient of 1 and a degree of 4. Okay? Moving along here. What is not a monomial is if your variable is not raised to an integer power where the integer is at least 0. So, for example, 1/2 is not an appropriate power for a monomial. When you raise any number to the 1/2 power, that means you're taking the square root. And for our polynomials, we don't want any square roots or cube roots or any other sort of roots. So you cannot have fractional exponents in our monomials or any other sort of polynomials. We also don't want any negative powers. So 4 times x to the negative 3 power is not a monomial as well. Alright, what we need is a coefficient real number times x raised to a non-negative integer power in order for it to be a monomial. Now, when we talk about polynomials, now the prefix poly indicates many. Of course, the nomials mean terms. So the polynomials, we're talking about multiple monomials strung together with pluses and minuses. All right, so some combination of monomials to make a polynomial. We typically will write polynomials where the highest degree term comes first, all the way down to the lowest degree term. The lowest degree term is this coefficient. Now, just a word about notation here. The a sub n minus 1, dot, 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 a sub 1, a sub 0. These are coefficients with the subscript of whatever you see the subscript of, n minus 1, and so forth. We like to keep things very general so we can talk about things in the more general terms instead of being boxed in with, specific numbers. So the a sub n's are going to be your coefficients. You have these powers on these various monomials. But the highest degree monomial is going to be the degree of the polynomial. The leading coefficient is the coefficient for the highest degree monomial. Okay? So for example, you have the polynomial negative 8x cubed plus 4x squared minus 6x plus 2. Well, this is a third degree polynomial because the highest degree monomial is this negative 8x cubed. Okay, the coefficients are negative 8, 4, negative 6, 2, but the leading coefficient is negative 8. Okay, and likewise for all these other ones. By the way, you have 3x squared minus 5. This is a second degree polynomial because the highest degree term that you see is the second degree term, the leading coefficient of 3. Now, you don't see an x term here, do you? But if you write it in as 0x, then you see all the terms there. So from time to time, we'll see that it's important to bring in a missing term with a coefficient of 0. Also recognize that when you have a subtraction of a term, that's just the really adding the negative of that number. So when you have minus 5, think about that as plus negative 5. Or if you have negative 2x plus x squared, as in 8 minus 2x plus x squared, you can rearrange that where the terms are in descending order degree-wise. Well, think about that as that x squared is 1 times x squared plus negative 2x plus 8, where the leading coefficient is 1 and the degree is 2 for the polynomial. 5x plus square root of 2. This is a first degree polynomial with a leading coefficient of 5. When you just have the number 3, well, you can think of it as a polynomial. A 0 degree polynomial. Even the number 0 is a very basic polynomial with a coefficient of 0 and a degree that is none. It's a 0 degree polynomial. All right, let's talk about combining polynomials by adding and subtracting. And folks, this is really straightforward. You have two polynomials and you want to add them. Well, you add them using like terms. So, for example, 8x cubed minus 2x squared plus 6x minus 2. You want to add that to this polynomial here, 3x to the 4th minus 2x cubed plus x squared plus x. Well, you'll just add them term by term. So you just collect like terms. Here you have your 3 times x to the 4th power. Then you add your x cubed terms. This 8x cubed comes from this guy, and this minus 2x cubed comes from this one right here. Then here's your x squared terms. That's this one plus this one. And then your x terms, which is your 6x plus x. And then your minus 2, which is this one. So how do you combine like terms? Well, you just basically combine the coefficients. What makes these like terms? Well, because they have the same powers of x. So 8x cubed minus 2x cubed will be 6x cubed. Negative 2x squared plus x squared. The negative 2 plus 1 is negative 1. So you have minus x cubed. 6x plus x is 7x minus 2. So the result of adding those two polynomials together will be the 3 times x to the 4th plus 6x cubed minus x squared plus 7x minus 2. Adding like terms. You could also add polynomials by the so-called vertical addition technique, by putting one polynomial on top of another and lining them up with like terms. So you get your x terms together, your x squared terms together, x cubes, x to the 4th, and just add vertically. Add your terms by adding the coefficients. So 6 plus 1 is 7, negative 2 plus 1 is negative 1, 8 plus negative 2 is 6, 3, and so forth. Same result, just a different way. Now when we subtract polynomials, we also do it by like terms. But the second polynomial, you'll just have to remember to distribute this subtraction operation throughout all of its terms. One way that people like to handle this is to turn this subtraction symbol into a plus and then distribute the negative sign throughout, where you're essentially just reversing signs. Okay, like that, and then you add. Basically what you're doing is you're taking the first polynomial plus the negative of the second polynomial. That's certainly a way to do it. But so let's go ahead and do the subtraction. You do it by like terms. You line up your x to the 4th terms together after you've taken the negative of the second polynomial. Get your like terms together. Your 3x to the 4th plus negative 2x to the 4th, and so forth. And then just combine your like terms. Alright, let you look at that real quick. You could also do it vertical wise, just like we did in the previous slide for addition. Make sure that you distribute the negative sign for that second polynomial. So then you're adding the negative of the second polynomial vertical wise. Moving along here. Let's review how to multiply polynomials. Take one polynomial times another. And folks, all you're doing really is just using the distribution property, the distributive property. So for example, 2x plus 5 times x squared minus x plus 2. Well, you can kind of, take the x squared minus x plus 2, distribute that to the 2x and the 5, or you could take the 2x plus 5 and distribute that to the x squared and the negative x and the 2. Either way works perfectly fine. If you were to take the x squared minus x plus 2 and distribute to the 2x plus 5, and then this is what it looks like right here. And then you use the distributive property again, where you take the 2x times the x squared minus x plus 2, and likewise for the other piece there. Multiply everything out, using the appropriate properties and laws, and combine like terms. Okay? Combine like terms. Now, we were using the horizontal multiplication method, but you could also use a vertical multiplication method as well, where you take maybe the larger polynomial times the smaller polynomial in vertical format like this, and then you just start multiplying like you do with multi-digit numbers, starting off with the 2x times the x squared times the negative x times the 2 to give you the first line. And then you have the 5 times the x squared minus x plus 2. Make sure that the left edge here corresponds to where the number that you're multiplying by is as well. And then you draw your horizontal line, and then you add the like terms. You get the same result as you did using the horizontal format. Okay, so that's something for you to practice, is your adding, subtracting, and multiplication of polynomials. Let's look at some formulas for some special products. Remember the foiling of two binomials together. Remember, a binomial is a polynomial with two terms. So you got one binomial times another binomial, and you can use the acronym FOIL, F-O-I-L, as in F means first, O means outer, I means inner, and L means last. So first, outer, inner, last. So you do the repeated FOIL distributions all at once. And then boom, you've got your second degree polynomial. That's the result of multiplying two first degree polynomials together. So for example, if you have x minus 3 times x plus 3, you can FOIL that out, F-O-I-L, to get x squared minus 9. Notice, by the way, that you've got two binomials that are conjugates of each other, meaning you've got a subtraction in the one term and addition in the other factor there. That's always going to give you a difference of squares. Here we have x plus 2 squared, meaning x plus 2 times x plus 2, which you can FOIL out to give you x squared plus 4x plus 4. Here we've got x minus 3 squared, same sort of discussion. But notice this time that this symbol right here is a subtraction symbol that corresponds to this subtraction there, the x minus 3 piece. Here we've got x plus 3 times x plus 1. FOIL it out to give you your x squared plus 4x plus 3. Notice that you have this 4 right here for the linear term. That's going to be this 3 and this 1 together. 3 plus 1 is 4. Here you've got 2x plus 1 times 3x plus 4. FOIL it out. 2x times 3x is 6x plus 8x plus 3x plus 4. And then combine the 8x plus 3x to make 11x. So you have 6x squared plus 11x plus 4 is the result. So just a reminder of the difference of squares. If you have x minus a times x plus a, the result will be x squared minus a squared. Also, if you have the square of a binomial, it's got this special form. Either if you have an addition in the binomial, like you see in the first example, or a subtraction. And the only difference between the two will be whether you see a plus or a minus, respectively, in between the first and second term. So if you have x minus 5 times x plus 5, can you just look at it real quick and tell me what the difference of squares would be? Well, you would be right if you said x squared minus 25. Or if you had the x plus 7 squared, and you could immediately think about that formula that you saw. Oh, that would be x squared plus 2 times 7, which is 14x, plus 49. Okay? Square of a binomial. 2x plus 1, that's another square of a binomial. 2x plus 1 squared. So think about that 2x, quantity squared is 4x squared. All right, plus 2 times 2x times 1, which is 4x, plus 1 squared, which is that one right there. Here we've got 3x minus 4 squared. 3x minus 4 squared is, let's see here, 3x squared is 9x squared. So there's your 9x squared plus 2 times 3x times negative 4, which is negative 24x, plus negative 4 squared, which is 16. All right, let's talk about cubing a binomial, meaning you take a binomial and raise to the third power. And it turns out that there's a special formula for that, for the cube of any binomial. Now, you could write x plus 2 cubed as x plus 2 times x plus 2 squared, but x plus 2 squared is x squared plus 4x plus 4. Then you can multiply out some more. X plus 2 times x squared plus 4x plus 4. FOIL it out, combine like terms, and you get your x cubed plus 6x squared plus 12x plus 8. So that's probably the easiest way without having to remember a formula. Or you have x minus 1 cubed is equal to x minus 1 times x minus 1 squared. FOIL out the x minus 1 squared, and then multiply out the x minus 1 times x squared minus 2x plus 1. Just like we did already. Combine like terms. And it turns out, though, that there are formulas for cubes of binomials. Here it is for the plus sign right here. And notice that for the, if you have an x plus a cubed, then all of these terms will be positive. But if you have an x minus a cubed, then you'll see kind of an alternation be between a minus and a plus and a minus. Okay, within the resulting third-degree polynomial. So, what if you saw this? What do you make of it? Well, multiply it out, and what you get, after you FOIL it out, combine like terms, you end up getting x cubed minus 1. So, think about this x cubed minus 1 as x cubed minus 1 cubed. Hey, after all, 1 cubed is 1, and 1 is 1 cubed. So this might give you some way of thinking about how to factor a difference of cubes. Let's take a look at this example here. You have x plus 2 times x squared minus 2x plus 4. What happens if you were to multiply this out? Well, let's go ahead and take a look at it. And that worked out to be x cubed plus 8. But you remember 8 is 2 cubed. So x cubed plus 2 cubed is x plus 2 times x squared minus 2x plus 4. So hopefully, just by using these two examples, you could see how to factor a difference of cubes and a sum of cubes. Now, difference of cubes, as in x cubed minus 8 cubed, could be factored like this. Or the sum of 2 cubes could be factored like this, where you have x cubed plus 8 cubed could be factored like this right here. Okay. So those are handy formulas to help you out. All right, moving along here. I'm not spending much time on anything because this is a review. But please let me know if you have any questions. And also, you'll have the chance to practice all this in the homework. Let's talk real quick about dividing polynomials. Using polynomial long division now to kind of prime ourselves, let's just recall how to divide a multi-digit number by some other number. For example, 842 divided by 15 by using long division. So here's how it goes. 842 is the dividend, 15 is the divisor. How many times does 15 go into 84? Well, that would be 5. And then you multiply. 5 times 15 is 7. Is 75, I mean. And then you subtract 84 minus 75. The result is 9. And then you bring down the 2. And then 6 times 15 is 90. Take 92 minus 90 is 2. And you've run out of digits to bring down from the divisor, so you're done dividing. And so you're left with this remainder of 2. So you can think about 842 divided by 15 as the quotient of 56 plus the remainder of 2, which you could write as 2/15. Okay. Okay. So you could think about this as the quotient times the divisor plus the remainder is equal to the dividend. All right, let you look at that real quick. All right, so let's go ahead and find the quotient and the remainder when we take this polynomial divided by this polynomial. We'll do it using long division. This is what it looks like used in the same sort of format that we did with just the numbers. But we use the same sort of process. You know, look at the leading coefficient of x squared and compare that to the 3x cubed. How many times does x squared go into 3x cubed? And the answer is 3x. So you put 3x up there, and then you multiply. 3x times x squared plus 1 is 3x cubed plus 3x. Right? 3x times x squared is x cubed, 3x cubed, and 3x times 1 is 3x. Notice that we have a missing term here, so you could write a plus 0x squared. And then you subtract. Make sure that you line up like terms, by the way. And then you subtract. And then we're down here now. When you subtract, and then you get 4x squared minus 2x plus 7. And then you repeat the process. You ask, how many times does x squared go into 4x squared? And the answer would be 4. So you'd put a 4 there. All right? So there's your 4. And then you multiply. 4 times x squared is 4x squared. 4 times 1 is 4. Subtract negative 2x. And then 7 minus 4 is 3. Negative 2x plus 3 is the remainder. Okay? So you can kind of think about this as maybe like this 3x cubed, I should say, plus 4x squared plus x plus 7 over x squared plus 2 is equal to, you see the quotient of 3x plus 4 plus a remainder of negative 2x plus 3, which we could write over the divisor of x squared plus 1. All right. Let's try it again. This time we're going to do x to the fourth minus 3x cubed plus 2x minus 5 divided by x squared minus x plus 1. Now, it's okay for you to skip a space. In fact, that's preferable if you have any missing terms in the dividend. And you set this up like so, and then you go through the same process. X squared goes into x to the fourth how many times? The answer is x squared. So you put x squared up there, multiply out, and this is what you get there. You subtract, and then how many times does x squared go into negative 2x cubed? The answer is negative 2x. And you multiply, subtract, and repeat the process. Negative 3 times x squared is negative 3x squared, so that's why you have negative 3 up there. Subtract, and you get x minus 2 as your remainder. So the x squared minus 2x minus 3 is the quotient with the remainder of x minus 2. Okay, so there's the result. Let's take a look at this theorem. Let Q be a polynomial of positive degree, and let P be a polynomial whose degree is greater than or equal to the degree of Q. The remainder after dividing P by Q is either the zero polynomial or a polynomial whose degree is less than the degree of the divisor Q. That is true. So, for example, if you have P divided by Q, where P is a polynomial, Q is a polynomial. Suppose that P is a fifth degree polynomial and Q is a third degree polynomial. Well, then the result is going to be some other polynomial, call it S or something. Well, a fifth divided by a third degree polynomial is going to be a second degree polynomial, for example. And that's a polynomial that's smaller degree than Q, which was the quotient. Or the divisor, the divisor. So the resulting polynomial is always going to have a degree that's smaller than the degree of the divisor. All right, let's just remind ourselves what it looks like to have a polynomial when you have two variables, as in x and y, or y and z, or whatever. Here you've got this polynomial here, 3x squared plus 2x cubed y plus 5. This first term right here has degree of 3x squared. This second term right here is actually a degree 4 term, because you've got a first degree for the y together with a third degree part for the x's. So you just basically add the exponents. 3 plus 1 is 4. That's what makes that a fourth degree term. So this is a fourth degree polynomial. There you've got a third degree polynomial with the variables x and y. Here you've got a fourth degree polynomial, where this is a fourth degree term, this is a fourth degree term, this is a fourth degree term, and this is a fourth degree term. If you just add the powers on the variables, they're all 4. But working with and doing operations on these polynomials with more than one variable is just like what we've been doing already, except you have 2 variables instead of just 1. But you treat the variables just like numbers. So for example, you have 2x minus y squared, well, you FOIL it out. You use that formula for the square of a binomial. You've got the 2x quantity squared plus 2 times 2x plus negative y, which gives you the negative 4xy, plus negative y squared, which is the y squared. Right? So you've got a polynomial that involves both x and y, and you have not violated any rules that we've already discussed already. Okay. All right. Hey, folks, let's take a quick pause because PowerPoint has just frozen up on me. So just a second. All right, folks, sorry for the interruption. So we're just finishing up this discussion. I had to restart PowerPoint. But what we were talking about, you have this binomial involving the two variables x and y, but folks, the process is still the same. You still treat this as the square of a binomial. Okay, so with the resulting second degree polynomial. Okay, so I'll let you look at that. You've got homework posted. I see some of you have gotten started with it already. I'm going to go ahead and post more homework for those of you who like to work ahead. And tomorrow I should be posting a lecture on section R5. Okay, where we're talking about factoring. Okay, folks, so take care, and I'll see you tomorrow. Bye.